This
examples of
conference will now be recorded.
Okay, now this conference is
Sorry
being
about
recorded.
that. Yeah. We forgot to buy-
Okay, so I'm listing here just a few examples of maritime service portfolios. We have several here that relate to safety of navigation. I think MSP 16 is very relevant for this audience here today because it's also environmental information. And the idea is to put all these products and services available through the concept of a single window where services providers and consumers, in this case shipping companies, can go securely and access that information and use it for safety of navigation and arrival to the port and coordination with the port services and all the things that need to happen to make them more efficient. So just an example of this MSDI dissemination concept and put in practice through IMO in the e-navigation initiative. Now, I pre-recorded a demonstration that I think is a good example of combining different services within this MSDI concept. And this particular example is about using artificial intelligence to detect shipwrecks in an area and create S57 objects. S57 is another IHO standard for electronic navigational charts, and how this can become part of an ENC or an electronic chart product. An example, but it could be coral reef, it could be shoreline extraction and other things, but I think this is pretty cool.
So Rafael, I hate to interrupt, but we're at the 2-minute mark. This is your 2-minute warning.
Yes, perfect. So this is going to last maybe 2 minutes and a half, but I will cut it before it finishes.
Okay.
So here you're seeing I'm consuming an ENC service from NOAA, and this ENC service is just a reference framework, because what I will do, and I cannot get rid of this thing. Anyway, I'm combining also a bathymetric service using bathymetric attributed grids. And from this high definition, high density bathymetry, in this particular area in New York, we can see a series of wrecks that we are using to train our model to detect wrecks. So we use this in this area to refine the model and train the model, and we reached so far more than 85% of positive detections. So now you can see the results of the algorithm in red. Those are wrecks extracted from the bathymetric attributed grid, and from this detected wrecks, we are now extracting S57 objects, and you can see in blue the S57 objects that are not just symbolized properly, but they are also attributed properly. And we can see the comparison between the S57 objects just extracted from the algorithm and the wrecks on the seabed from the bathymetric surface. So what we are doing with these wrecks now is making them available in the electronic navigational chart. Of course, in this particular area, all these wrecks are not a danger to navigation, but because we can also detect the depth, and we can extract the shallowest point of each wreck, we can also tell the system to give us the dangerous wrecks for navigation and extract only those that would be pertinent for safety of navigation purposes. So you can see here when I'm querying the S57 object is fully attributed and ready to be used in nautical charts. So that's it. I would like just to give you with some take-home messages. I would like to say that an MSDI is the mean to collaborate and disseminate geospatial information, and that's the mean, and the end is to provide geospatial data and information products to the largest extent. And I think that concludes my presentation. Thank you very much for the time, and happy to be the closer of this series. And if there are any questions at the end, I would be happy to answer them.
Yes, actually, thank you so much for joining us today, Rafael. I'm sorry that this was your first one. I'm glad that you were here. Next time we'll get you in earlier for sure. But again, I want to let everyone know, one of the things I forgot to mention is that we will have time at the end for questions. So, I mentioned about putting your questions in the chat box. If you've got questions for Rafael, please put them in the chat box. After everybody's presentation, we'll circle back around to that. And also, if you scroll back up in the chat box, you'll see that Ali had posted a link to today's agenda. So a lot of the information that Rafael was talking about there are links in the agenda, to blogs and to resources and to services that Esri provides, as well as the other speakers today. Their links to their tools are out there. More descriptions are out in the agenda. So with that, I think I'm going to turn it over to Stephen and let Steve take over and start talking to us about CWWED. And I'll let him tell you what that means. Stephen, it's all yours. And you're on mute. Hashtag.
I'm trying to unmute him, and I can't.
Sorry about that. Can you hear me?
Oh, yes, loud and clear. Perfect. Thanks.
Great. Hi. Yeah, I'm Steve Del Greco. I work for CERIS. CERIS is a cooperative institute out of the University of Colorado Boulder. And my talk today is going to be on CWED. CWED is a Coastal Wind and Water Events Database, and for short, we call it CWED. CWED actually supports the Coastal Act. And if you're not familiar with the Coastal Act, in 2012, July 6th of 2012, Coastal Act was signed into law. And basically, it's a result of Katrina. In the aftermath of Katrina, insurance companies, you have FEMA that insures for flood, for water, and you have private sector companies that insure for wind. They are at odds in regards to payouts, adjudicating claims. One thought, hey, this damage is mostly wind, while the other thought it's mostly water. So an act was signed into law in 2012. Funding didn't come in until 2016. So we've been developing CWED in support of the Coastal Act for the last 5 years. We're in the 5th year of development funding. So I should say this development work right now, I should put this disclaimer out there. This is pre-decisional to go into operations. The idea would be this goes into operations 2022. That said, our operations budget request has just passed the Senate. So we're looking, it's got to go to the House. So we're looking, it looks like the Coastal Act will go operational in 2022. The idea here is when a storm hits, a post-storm assessment enactment would occur. And what that means is there will be a suite of basically hindcast products, model products post-storm that the insurance companies will need to use to kind of as their benchmark, kind of hang their hats on what percent at a certain point in time was water damage versus what is wind. And that's what they'll need to use to adjudicate claims. So where does CWED fit into this? Well, CWED actually is the database that supports the Coastal Act, both on the front end and the back end. And if you look at this simple schematic I have here, basically what goes on, we through a federated process, CWED has built protocols to NOAA, to USGS, to other entities that would provide data, which is basically the base for these integrated products, these hindcast type products. I said NOAA and USGS, but it also includes other players. For example, there's a consortium called the Digital Hurricane Consortium, which are academic members. The universities often will deploy instruments in front of storms, in front of hurricanes, and we'll have access to that information as well. An example of that would be the University of Oklahoma with their mobile radars. So we're in front of the process where we, through a federated process, pull what we call cover data. We pull these cover data, which is the intermediate data that would be integrated into a post-storm assessment product. We pull that into CWED. We bundle that, or I would say grab a snapshot of that information for a certain point in time, and put the proper metadata as well as metadata there, and we send it off to to NCEP, the National Center for Environmental Prediction, and they run the model ensemble there. The name of the model ensemble is the name storm event model. That ensemble, in turn, provides a suite of these post-storm assessment products. These products are basically, water projects, max wave, surge, things like that, as well as wind products. Those products then come back to CWED, and we basically store and steward those products within CWED, the database itself, and provide services. We provide both back-end services and front-end services. What's a back-end service, for example? Well, we have an API that can talk to FEMA's API. So if FEMA wanted to pull wind and water information over a structure, over a house, anything, they could come into the system through a machine-to-machine process and pull that data. And that's the back-end piece. But we also have the front-end web services, and that's what I'll show in a minute. That's the real guts of this tool. The front-end services, basically, we display and visualize the data, and you can, through a front-end service, you can discover and disseminate harvest information, the data and information. You can also apply some visualization tools to it, like, for example, GIS-type tools on the front end. The main stakeholder is FEMA, okay, and insurance companies. However, we have built this in a cloud platform. It's on AWS, Amazon Cloud Platform, and we put it in the public domain. So while our main stakeholder would be FEMA, the data is available to everybody in the public domain. Some of the components that go into this, I'm just going to show real quick. These we call the cover data, but these are the different types of components that would go into the model. And I just have basically some narratives on some different products here that you can see that are actually integrated into the post-storm assessment suite of products. These we actually also have built-in protocols. So if one wanted to get access to the underlying data that goes into the product, they would be able to do so as well. And I'll show that, how we can do that later on. The post-storm assessment itself, we have two storms that we've used in the development of post-storm assessments. One is Florence and one is Sandy. I will say this, the two post-storm assessment hurricanes that we've used to derive products while in development are actually Atlantic storms. And I recognize this is a Gulf, alliance meeting. However, the tool basically supports the whole eastern seaboard, the Pacific, western seaboard, the Gulf. It also supports Puerto Rico, Guam, and Hawaii, so our other territories. The way this works, if you go in and you want to look, this one is Sandy, for example, you basically can look at the different map layers. We have layers you can turn on and turn off. We have a water level. We have a max water level. We have wind barbs that you can depict, as well as wind speed. That's a contoured product. You can support the opacity on this. You can, make it darker or clear. And once you have structure underneath, if you want to make it a little clearer so you can see structure underneath, and I'll show you that in a minute, you can do that. And we also have a time series where you can just do a slide and bring up different points and times for the product itself. There are legends, so once you turn on certain layers, whether they're water or wind layers, there are legends that you can look at. There are different base maps. Here we just have a streets map, but I can switch it to other ones, for example, satellite map. And then there's a get data. So from here, you can actually, and I'll show you this in a minute, you can click and you can export data from the map you're looking at yourself. You can expand this. So I just blow this up to the full screen, and there's several things we can do, zooming in and zooming out. There's a mouse over feature here. If I want to look at a certain point in time based on what I've clicked, like water level, max water level winds, it gives me at that point in time what the value is there. It also gives an accuracy. And if you look at that accuracy on here, what that is the Weather Service, the modeling center is working on a scoring thing. So it's a confidence level saying, okay, based on the input, the information we've input and integrated into this guess field, this is what we feel the accuracy is for this point in time. And from here too, you can also click where you are and pull up a time series. So right where I've clicked to pull up a time series, I've got the features turned on, a water level, wave height, and a wind speed, so you can see that. I also have a CSV. So right at that point in time, I can click on this button. I'm not going to do it, and it will download to your computer a CSV file for that. You can also actually search by clicking a little search bar here. I'm just going to put in something that would be on here. Let's see, Ocean City. And it would zoom in to where you are. So if you wanted to zoom in to right over an address or structure, you could do that. And from this feature here, and this is the part that I feel is powerful, we have a bounding box. So you can click on a bounding box and basically put it around that structure. And once you do that, go down to get data, and you can now download that into different formats. Our base format is NetCDF, but we've also provide a CSV format, a shapefile for the Esri guys, a GeoJSON as well for GIS guys, as well as a KML format for people that are going to use like Google Earth. We're thinking about a couple other formats. GeoTIFF is one that comes to mind that we'll probably also put into this export feature. Okay, so that is that, and again, we have two storms that we're looking at, but before we go operation, we've got a couple other storms that we will probably put into the development piece of this. This goes operational again in 2022, so we continue to improve and revise the database as we go along. I mentioned covered data, so anything that goes into our product, our post-storm assessment suite, we do provide that information if you want to get to it through a process. Basically, the storm snapshot, and go in, I click on this, and it actually through a protocol, I can get to some of the data where it resides. For example, here's the USGS. I click on this, I click on Sandy, and through an OpenDAP process, it brings me to the type of information that are supporting the Coastal Act, that are parts of the covered data, for example. For example, here I just clicked on this, and these are NetCF formats, but these are what do I have here? Water level files. So in a nutshell, that is our product. Again, this goes operational in 2022. And right now we're in the process of moving away from development. We're in our 5th year of development funding and moving towards operations. Thank you.
All right. We've got a little bit of time. Does anybody have any questions for Steve? All right, so actually I have one question for you real quick, Steve, before we run out of time. When you were talking about getting and extracting the data or exporting the data, do you have to use that select tool and select a bounding box for that? Or if you just say get data, can I get the entire data feature class, or is it bound by the map extent, or do I have to use the bounding?
We do have a back-end API process, so you can actually get data. You can get the whole data set through a process where you're not using basically kind of these front-end kind of GIS features for grabbing information. I think the real power of this is really the back-end machine-to-machine pulling data via an API.
So that leads me to my next question. So that's actually very, very good, and I'm glad that you guys are providing that service, because that, there's several tools that are out there. Don't want to highlight multiple tools over this series that you capture services, API services, web services, and then can ingest them in their own applications. So we've got one that's looking at that right now. So, being able to pull in some of those larger data sets or those
Yeah,
data set as app would be very, very powerful.
and that's where I think the real power of this is. You could basically have a RESTful application and set up what variables you want to pull back. So you could do that totally through a machine-to-machine process. Another thing where I find this to be powerful, well, our stakeholder is FEMA, and this is basically, enacted so you can basically help adjudicate claims, whether it's wind or water damage with these future storms. We'll be building a database of these storms as well within that. And the database, basically, we're holding data at a high level of granularity, with robust metadata. So if we've got people that are doing work in basically resilience and adaptation fields, they would be able to actually look at climatologies across storms. And so once we build a kind of a time series of multiple storms, it'd be real interesting to look at basically the physics between storms at a certain point in time. And I just think that could help build some type of forecast or some type of a resilience or adaptation tool. So I come really from a background of meteorology. While I do a lot of oceanography work, to me, with a background of climatology, that's pretty exciting to me.
All right. We had a question that came in the chat box for real quick, and the tool is online, but is there a link for this tool out there yet, or are you're getting ready to deploy that?
There's a link for the tool. We haven't advertising it because we're still in the disclaimer that this is pre-decisional, though it is out there, so people have found it. If somebody's interested in actually going in and looking at the tool, even though we only have like 2 storms in there and it's all basically in the experimental end, I can check with Weather Service to see if they feel comfortable releasing it at this point.
Okay, so thanks, Heidi. We'll see if we can find a link for you, and Steve, if you can do that, just let me know, and we'll make sure we publish the link.
Yeah, you know what? I'm making a note right now about a link. Okay, and I will get back.
Perfect.
I will get back to you, Dave, tomorrow on that. Okay.
All right. I will eagerly await your email.
Okay.
All right. So let's switch gears now. I'm going to talk to Dr. Chris, who's going to be talking to us today about the Resilience Dialogues Toolkit. So, Dr. Chris, it is all you.
All right, thanks, Dave. Just a minute, I've got to try to remove things so I can start my slideshow. Sorry, there's so much extra stuff, I can't get to the place to click.
Isn't that the truth? Yeah, I think we all can just relate, right? There's so much extra stuff out there. What the heck?
Yeah, so I can't, just a minute, let me try to get rid of it. I'm so happy to be here, and I'm just blown away by the 2 previous presentations. This one, if I can ever get it started in the normal phase, will be quite relaxing. And there we go, because it is a different kind of tool. There we go. Oops, let me go back one. All right, sorry to take so long. So the Resilience Dialogues Toolkit are resources that you can use if there are any of you on the call who are not supreme data geeks and you also interact with everyday humans who live in communities. This is the tool for you. So the resources are for collaboration, conflict management, and stakeholder engagement. So it's a little bit different kind of tool. I work at the Wells National Estuarine Research Reserve in Maine, but I am presenting on behalf of the 14 reserves, including the Gulf of Mexico reserves, who helped put these tools together. So just to define what a resilience dialogue is, resilience dialogues are conversations that occur among people with diverse perspectives who have agreed to collaborate to improve a situation that contributes to building social and ecological resilience. Now, the time that I actually gave a training on these resources was on the Gulf Coast, where I was hosted by the Weeks Bay Reserve and the Grand Bay Reserve and presented these tools to 35 coastal managers on the Gulf of Mexico. So I was able to hearken back to 1 year ago when no one was wearing masks and we were all together in the same room. So that was a little bit of nostalgia. So that you can do a little check, here's the full definition. So to see if you can use these tools. So resilience dialogues are conversations that occur among people with diverse perspectives. And I can just guess that all of you are involved in these kind of conversations. One other caveat is these are people who have agreed to collaborate, and their goal in working together is to improve a situation that contributes to building social and ecological resilience. So kind of go through that checklist and say, yeah, this is a tool for me. So the tools are designed for the people who design, facilitate, and engage in resilience dialogues. So if you are not that specific person, hopefully there's someone from your organization who does this kind of work. And I hope you do me a huge favor and share this with the people in your organizations who do this kind of work. So if you're unfamiliar with the National Estuarine Research Reserve System, it's a place 29 marine protected areas shown here on all the coasts of the US, including quite a few on the Gulf of Mexico coast, soon to be adding Louisiana as a future reserve. And 14 of the 29 reserves participated in creating these tools. So it was a combined effort. And in the reserve system, the job that I have and the people that created these tools is called the Coastal Training Program. And the Coastal Training Program at each reserve works with local stakeholders, coastal managers, state agencies to bring science to bear on coastal management problems. And this is the work of that group of people. And the history of how the tool came to be created about a decade ago, the National Estuarine Research Reserve System kind of changed their approach to doing research. And the new approach of collaborative science was from the beginning of any scientific research, the project was engaged with stakeholders so that research directly influenced decision making. And for the past decade, all of the reserves have been learning this new paradigm of engaging stakeholders and community members in reserve science. So what the goal of our project was to talk to the people who were in charge of the stakeholder engagement piece. And those people are called boundary spanners. They're the ones that have a foot in both worlds. They have a foot in the world of science and a foot in the world of education. And their role is to span these difficult boundaries and bring people together around problem solving. So the Resilience Dialogue Project looked for 10 years of what have we learned from doing this and how can we share these lessons more broadly. So the training resources we created were to create an in-person training, to develop it during the course of the funded project, and then deliver that training and tools more broadly to help people engage in training. Now, all the links in my presentation are on the website for your Tools Cafe, so you have easy access to those. Now, the individual tools in the toolkit, here's an example of 6 of them. If you or someone you know was organizing a group of people to work on a new project, this could be a planning team, or it could be a team where you are developing, say you're developing a technology tool, and you want to be sure that the end users or the stakeholders understand it. So these are the tools in the Resilience Dialogues Toolkit. How to conduct a needs assessment to see if the people you think need your product actually need it. How do you conduct a stakeholder assessment so you bring the right people to the table? Then how do you work with the stakeholders to create a situation map? This is in essence an activity about systems thinking where you're going to tap the knowledge of everyone in the room rather than creating something that you work on for years and then you go to the stakeholders. It's a different model, and that's what the reserve's been doing. We also have a tool around assessing and preparing for conflict, and also how to identify what it is that everyone cares about. How do you maximize the collaborative potential? What are the values that people share? Could be attachment to place. It could be commitment to future generations. And how can you build on that in your process to keep people engaged? And then the biggest tool of all is the actual, how do you design and conduct a collaborative learning process? So each of these components are part of the primary toolkit. The other thing we had to do as we did this project, we wanted to showcase where people are using these tools. So you might think, well, that looks like a good tool, but I don't know if it really works. So we went to 4 reserves who were using the tools and used best practices. And we created resources so you could travel virtually to the 4 reserves and see what it looks like to actually use these tools. So we went to the Deal Island Peninsula Project, which is Chesapeake Bay, Maryland, the Buffer Options for the Bay Project in Great Bay, New Hampshire, Sustainable Shorelines in Hudson River, and Protecting Our Children's Water in Maine. So these are part of the case studies, but again, the people from reserves, even on all the coast, participated in creating the resources. I just want to tell you a little bit more about each of the case studies so you know the kind of tools that were used there. In Deal Island, the issue is land subsidence and erosion. And people, the scientists who were studying sea level rise and erosion on this side of it's the Delmarva Peninsula of Chesapeake Bay, they wanted to interact not only with resource managers, researchers, they wanted to interact with the local communities. They wanted the watermen of the Chesapeake Bay engaged in the project. They wanted people to define what resilience meant to them. And as they pursued the science on this project, they wanted the community to be engaged. And the structure for doing this, for this boundary spanning goal, was to use collaborative learning. The collaborative learning process was used in a number of these approaches, and the Resilience Dialogue Toolkit essentially gives people the tools to design their own collaborative learning process. So if you think of the scientific method that we all learned in, what, 2nd grade, everyone knows the scientific method. But when you get to this boundary spanning activity of engaging people in dialogues, it's not the same scientific method. Well, what's so cool about this collaborative learning tool is it's a scientific method for doing boundary spanning. It's easy to understand, it's easy to learn. I've taught at the University of New England for 20 years, and these same tools that I'm using with practitioners and with the reserve system, I was able to teach this to undergraduates so that when they graduated, they had this tool in their back pocket for organizing people. The second best practice was the Buffers on the Bay project, and this best practice was doing an assessment of the social ecological system where the project is embedded. So in the Great Bay Reserve in New Hampshire, one of the biggest problems in the estuary is nitrogen pollution to the bay. And literally millions of dollars have been spent studying nitrogen input into the bay, but the needle wasn't moved on decision making. So in this project, the goal was to do an assessment that was not only measuring nitrogen, but measuring the ability to communicate what the community cared about, what the policies were, and an economic study. So this particular best practice was the role of assessment. The third best practice, and this is something I heard both previous presenters allude to, is having a common language. And the common language for the National Estuarine Research Reserves is not just the language of science, because we're really closely interacting with our communities. So any project that uses best practices has to develop a common language that includes local and indigenous knowledge. And in the reserve on Hudson River, where they're working on sustainable shorelines, the person leading this project for collaboration, the first thing she had to do was make a lexicon so the engineers could talk to the biologists and the managers and the town planners. And this is another one of the 4 best practices for resilience dialogues. And then the last best practice relates to mental and cultural models and how you can work with a group and discern what mental and cultural models they're using to understand the situation they're trying to work on. So one of the tools we developed was an assessment activity where a facilitator engages people from diverse backgrounds in understanding each other's mental models and cultural models of what is going on with the situation. So this very much builds a systems understanding of the problem that's being worked on. Now, all the resources for the training are available on the Wells, Wells Reserve website, including the slides for the training and the examples and webinars for best practices, because it was designed that we had funding to develop the materials, and then the reserve system would continue to deliver the materials. So the things we've got in the toolkit for so far, we've got 4 modules of the best practices. We've got worksheets, the case studies. We provide technical assistance, and we've begun to convert the trainings to virtual trainings. I did a training last month with the Rookery Bay Reserve in Florida on the mental models and cultural models component. So we engaged people in learning how they can assess mental and cultural models to build systems understanding. The reserve system also got certified to deliver a training called Crucial Conversations. So the reserve system is now delivering that. We've given 3 trainings this year, and we were scheduled to come to Mississippi again and do the Crucial Conversations training in April, but that didn't happen. So Mississippi's still on the list to come in 2021. So I have my contact information here. Please do not hesitate to get in touch with me if you'd like to learn more, or if as you look at the resources, you'd say, well, I like this piece. Could you do a virtual training on that piece? That's what the materials are for. I can do that from the Wells Reserve, but I can also work with all the reserves on the Gulf Coast. I always have to say Gulf of Mexico because we are the Gulf of Maine. I actually did a project with Texas called Bridging the Gulfs, where we worked from the Gulf of Maine to the Gulf of Mexico on this kind of work. So thank you very much for the time, and I'll look forward to any questions you might have.
All right, thanks, Dr. Chris. I appreciate it. That was actually very, very informative. And I think what I'd like to do is I'd like to hold questions. I'd go ahead and flip over to our last and final presentation from Dina and Brad. They're going to tag team this. So we'll come back with and catch questions for you at the end. So Dina, Brad, I think you're on. I'm ready to go.
Yes, this is Brad. Can you see my screen okay, Dave?
Yeah, good.
Excellent. All right, thank you very much for having us here today. I'm Brad Pickens. I'm with CSS as a federal contractor with NOAA National Centers for Coastal Ocean Science, and Dana Hansen from the Bureau of Ocean Energy Management will be speaking with us today too. Move ahead here. So we have a broad project team, including Bureau of Ocean Energy Management, Dana Hansen and Laura Turner, really gave input throughout this project and made sure that BOEM got the tool that they were looking for. Myself, Brad Pickens with NOAA, alongside Chris Taylor and Mark Finkbeiner, really looked at the science side of things. And then with Quantum Spatial, Liz Rogers and Alexis Ramirez were the designers of the tool to make it make it user friendly and to make sure we got everything we can out of it. So as some background here, before we get into the tool, the demand for marine sand has increased rapidly in the past couple of decades. Marine sands are used for beach renourishment and barrier island restoration, particularly in the Gulf of Mexico. Demand for offshore sand has increased rapidly alongside the depletion of nearshore sand resources. And of course, there were plenty of storms this year and in the recent years, and that's driving things, as well as coastal infrastructure and the economic value of tourism. So dredging of sand shoals is the most efficient method to obtain marine sands. These are large topographic features in the marine environment, and they can span a couple kilometers wide and several kilometers long, if not more. So sand shoals are designated as essential fish habitat, but the extent of shoals are largely unknown. Essential fish habitat consultation is required with NOAA National Marine Fisheries Service for sand dredging, yet we know little about the shoal habitat value to fish. And really what we're looking for here is a consistent science-based assessment of fish habitat value so we can implement and support a more strategic approach. So essential fish habitat is designated in law to protect fish habitats. And you can see here a couple examples of designations of reef fish and tiger shark as examples of one of many. These are federally managed species, and EFH does provide protection of fish habitats, but it doesn't necessarily provide very fine-scale detail necessary to make local decisions. So, for example, if you had 3 options of places to do sand dredging, you really wouldn't see any difference biologically from this data. You wouldn't have a place that was more valuable to fish and less valuable to fish. So this is the overall framework of our study going clockwise here. Basically, all these things are going into ShoalMATE, the shoal map assessment tool for essential fish habitat. That is our decision support tool. And so we have dredging history going into the tool. We have the designated official essential fish habitat spatial depictions going into the tool. We have a literature synthesis, which summarizes potential dredging impacts and fish habitat associations going in. We have sand shoal identification and classification. Basically, everything we know about the sand shoal under consideration is going into the tool, and I'll talk about that here today. And then we have fish species distribution model. So is this an important place for fish or not? And that is going into the tool as well. And the tool does even more. It brings not only brings all this data together, but it also outputs an automated report for essential fish habitat and maps to go along with that. So we really coalesce all this data and output it. So the study area includes the extent of the Atlantic and Gulf of Mexico that are relevant to dredging in federal waters. This is restricted to the tool is restricted to offshore federally managed waters less than 50 meters in depth, so shallow waters of the continental shelf. So first off, this is the content that is going into the tool. So we conducted a C4 classification using distance to shore and some geomorphology metrics. So basically, we're looking for shallow areas that are shallow areas plus areas that have a high relief, a high topographic relief, and that have a slope on them. So you can see from that classification that we identified sand shoals throughout the Atlantic and Gulf of Mexico. Let me zoom in here, and you can see how this relates to some of the known shoals out there. You see Trinity Shoal, the previously mapped identified sand resource, a map from BOEM, is in the brown outline, and the pink depictions are the sand shoals that we were able to model. So you can see that it fits those shapes very nicely. So we're able to quantitatively validate these data. The data is available on BOEM's MMIS online viewer, which is from BOEM's Minerals Management. And we have an article in Press in the Journal of Coastal Research. All right, so within shoals, we have even more information here. We used a classification scheme called the Coastal and Marine Ecological Classification Standard. And this classification scheme is developed from expert opinion and workshops to describe shoals, basically everything we know about shoals in relation to fish and dredging. So you can think of this as a hierarchy. So we have a shoal complex, which would be multiple shoals, maybe some swales in there as well. And then dropping down to the next level, we have individual shoals. And then dropping down another level, you can see we divide these up into really geological origin and hydrodynamic processes, such as a bed form shoal or cape-associated shoal. In the Louisiana and Texas area, it would be isolated shelf shoals. And that really responds to what the geological origin of those shoals are. And then we have a lot of information, really detailed, getting into sediment grain size, sediment color, and heterogeneity, and all those things we thought relevant to both dredging and fish. So all this content is in the tool. We did select species for habitat modeling. So looking at the distribution of fish, we mainly filtered for species that were designated with essential fish habitat and would undergo scrutiny here for consultation. And then species that were documented using sand shoals. So we targeted those species that were most relevant to sand dredging. For the Gulf of Mexico, this included 8 species, including the 3 Penaeid shrimp of economic importance, juvenile red and lane snapper, and blacktip spinner and Atlantic sharp-nosed shark. And you can see there we did modeling as well for the other regions. The modeling part, these maps, this end product here is going to be quantified in the tool, so keep that in mind. And we use fishery independent surveys and really put together about 34 habitat factors. And from this, those graphs there are simply representing the species habitat relationships. And for example, if there's the last graph there, actually in the lower right, is a positive association between shrimp and nearby wetlands. So the output of that is actually a species distribution model, which predicts if you go out and do a standardized trawl survey in area X, you'll get 590 shrimp. That's basically predicting the number of shrimp or fish that you will catch given a standardized survey. And those models you see there, the blue is the lower catch per unit effort, and the red are the hot spots where you'd catch more fish, where you're more likely to catch a certain species. A couple of big drivers of things overall were mixed layer depth. You can see there on the left side, there's a current going up northward up the Texas coast, and that is an area of mixed layer depth where the mixed layer is deeper, so there's more mixing going on. Seems to be more productive because a lot of the fish were responding to those areas. We also have the loop current going on in the Gulf of Mexico, and eddies spinning off westerly, west of the Mississippi River, and that seemed to be driving fish distribution as well. Area of nearby wetlands was another big driver of species distribution. And some of these species that we looked at in the marine environment were dependent on estuaries for juvenile life stages. So that shouldn't be a big surprise, but you can kind of picture this as if you were in a boat in the Gulf and you drew a giant circle around you and you calculated all the wetlands within that circle, then you'd get a map like this, all right? So that's probably not a surprise to a lot of people that Louisiana, west or eastern Texas would have a high amount of wetlands and probably have some of those estuary independent species in the marine environment. So this is the data itself, the model outputs. You can see on the left side are shark species, spinner, blacktip, and Atlantic sharp-nosed shark. And again, the orange and red areas are higher probability of occurrence or greater catch per unit effort. So more fish on those orange and red areas. On the right side, you can see the snapper species. We broke those into age group, red snapper age 0, 1, lane snapper age 0 and 1 as well. And this is, and these species are in addition to the 3 Penaeid shrimps that we modeled as well. So some broad conclusions of fish and shrimp modeling. The value of sand shoals, we thought it was actually going to be, a hit or miss. So we thought it was going to be either the shoals are going to be really good for shrimp or certain shrimp species, or they're going to be really bad for certain fish species. So it turns out that the value of sand shoals to fish is really highly dependent on oceanographic conditions, area of nearby wetlands and estuaries, and prey. So the value of sand shoals really depends on the context of the waters. There are a few relationships with geomorphology. We did have a expected relationship with red snapper and sand shoals, and so that was good to see, but it was still of minor importance. So they were, the broader scheme of things was the ocean characteristics were really driving things. I do have the report there with the web link if you would like that, and I can put that into the chat box. And I just want to emphasize here that we're really looking for refinement of information to make decisions. So you can see again the blacktip shark essential fish habitat designation compared to the refinement we're able to accomplish with blacktip shark and probability of occurrence. So obviously there's some areas that are really important for blacktip shark, and there are areas that are not. And you can see there with the shoals in pink there too, that some of those shoals are really important to blacktip sharks and some are not. So I want to emphasize that our analysis for the tool is very much shoal based. So I circled Ship Shoal there off the Louisiana coast with our prediction of red snapper catch per unit effort in the fall. And our tool is going to output the predicted fish abundance at the shoal. And then to give that context, we also calculated the predicted fish abundance within 20 kilometers of the shoal. So in this case, red snapper are going to be slightly more abundant on the shoal compared to the area around it. And then as another measurement,
Right,
we
2
use...
in the morning, sorry.
Oh, I'm sorry, 2 minutes?
Yep, 2 minutes.
This is the predicted predicted fish abundance at the shoal compared to the Gulf of Mexico range. All right, and can I hand that over to Dina?
Great, thank you, Brad.
Yep.
Okay, so when we pull up ShoalMATE, this is on BOEM's servers because again, it's so specific to what we're doing that we, that we really want to keep it on our servers because it's something that we're using as a decision, but it's very specific to dredging. So just to show, we are going to say begin an assessment. I'm zooming into Ship Shoal off of Louisiana. When you make a selection, if there are multiple areas, you can kind of choose out of which one do you want to run your assessment on. So you can use an existing borrow area, or you can use a modeled shoal, which is this other area. And then what you want to do is add the season that you're looking at. And so I'm trying to get rid of the GoToMeeting box is blocking me. Okay, so let's select that area. And then like Brad said, what this does is this tool integrates all EFH species. So I can, when I intersect all EFH, this is the actual designated sort of legal designation of the different species, the life stage, and the season that they occur at this shoal. We can also look at habitat areas of particular concern. And then of course the models that Brad was talking about, where we have shows these individual species distribution models, their occurrence on the shoal and the within shoal or borrow area probability of occurrence compared to a wider footprint and then compared to the entire geographic range. And so that way we can look at kind of a comparative analysis of whether or not they're more abundant on a given shoal or if they're more abundant in the region as a whole. And then another cool feature that we have is these maps. So we have some kind of predetermined maps that will show the general footprint of the area, kind of overview maps. We also have maps that show depth, bathymetry, or bottom type. So we can look at the different oceanographic features of how this shoal is, or the borrow area is situated. So this includes current direction. And then in addition to the sort of standard maps, we've also created the ability to create customized maps. So we can include hard bottom areas. We can include, I know in the Gulf of Mexico, the pipelines are an important feature. So we want to know where all the pipelines are, so we can add that to our map. And then any customized map that you have, you just simply select add to report, and it gets imported into your final assessment report. And there are obviously a million different iterations you can do, so you can kind of make it site specific as to what your particular concern is for a given area. And again, this is internal to BOEM because we have such a specific need, and we don't want this to sort of be used out of context. But some of the layers are available on our marine minerals information system. So like the modeled shoal layer is available, and the species distribution models will be available through NOAA's server as well. So I try to keep it short, but I look forward to any other questions that you might have when we get to the Q&A section.
Well, that's a great segue, Didi, because we're there now.
All right.
So this is actually a big round of applause for all of the presenters today and for our sponsors. Before people start cutting out and leaving, I do want to give, I think there was a question for you, Dina, and Brad in the chat box. The species CPUA data broken down for life stage or seasonality?
Yes, the shark data is from surveys, based on surveys from March to October. So that's what they represent. And the trawl surveys are in summer and fall. So that's what they represent. And then life stages, the sharks are broken down in our report. You can see that, but those are individuals caught in federal waters. They were primarily juveniles and adults. And for the shrimp as well, those were the shrimp caught in the trawl surveys, the adults.
Okay, so thank you. I actually won't give everybody an opportunity to question before I ask mine. Anybody else have a question for ShoalMATE?
There was a question that was sent to me privately.
Oh.
Oh, wait, she just reposted it. Here you go.
Oh, there we go. How does the tool adapt for changes in essential fish habitat over time? That's for you guys, Dina and Brad.
I think the tool is integrating the web service, and if I'm incorrect, you
Yes.
chime in, Dina.
Yeah, so we have, and we also have flags because essential fish habitat is legally supposed to be updated about every 5 years. And so we have those dates flagged so that when the review and updating time comes, we know to keep an eye out for it and that we can update any new designations, either both with the actual map layers as well as we use some of the written EFH descriptions in our kind of analysis of seasonal overlap and sediment preference. So that kind of information would be updated, but there is a bit of a manual aspect to it where we have to just track when those dates, those 5-year increments arise.
Excellent. All right, so you guys are on the hot seat because we got another question that came in for you guys. Does BOEM, all right, so does BOEM make available in the ship shoal model access to bathymetric survey data for pipelines?
So if I'm understanding that correctly, whether we're making the actual bathymetric survey data public. And so this is a bit outside of ShoalMATE, but related. So in our Marine Mineral Information System, or MMIS, and I'll put a link in the chat to that, that's where we have data that's, I think, probably more in line with this question. And that's where we house all of our public data, where we bathymetric surveys. But I believe we just have the survey track lines and not the actual bathymetric data. But I'll have to check on exactly what is hosted there. But I'll put a link in the chat in the meantime.
Excellent. All right. Any other questions for ShoalMATE? Well, guys, thank you very much for doing that. We've got a question for, but we're going to get back to that. Let's go back now to Dr. Chris and the resiliency tools. Does anybody have any questions for Dr. Chris before I ask mine? Because I had one. All right, Chris, here you go. You ready?
I'm ready.
Still on? Okay, good. All right, I just want to make sure you're not muted. Okay, here we go. So when you were talking about your toolkit, you had flipped up on the screen a list of 6 tools. You said, well, here are 6 tools. How many tools do you have in your resiliency toolbox for your dialogue? Or do you have more than just the 6 that you threw out there?
I think the 6 are the primary tools, but that last one, like designing a collaborative learning process, that's a really big tool. That's like the overarching, creating the architecture within which all the other tools work. So that one is the biggest one, and that's the one, if you were designing a process, you'd use that, and then you'd select the other tools within that. The other kind of new and complex one is the mental and cultural models tool, because not as many people are familiar with that. It's a tool from anthropology.
That's way outside of my realm of knowledge, but yes, thank you. That's awesome. All right, so I think everybody grabbed Steve when he was presenting. So we've got one last question before I cut everybody loose today. It's back to our sponsor. Raphael, you've got one in the chat box. How do you envision bathymetric data being made more widely available so non-traditional users can easily consume this bathy data?
All right. Very good question. Yeah. Well, bathymetry is perhaps the most important asset that hydrographic offices provide. And so far, it has been used mostly for safety of navigation purposes, for extracting soundings that will be used for nautical charts. But yes, bathymetric data is very important for everything that happens in the water. I mean, it's the foundation, it's the framework for everything else that you want to put in the water. So I think there are some good initiatives out there, and I mentioned the Seabed 2030 project in combination with the crowdsourced bathymetry project of IHO. And that's, I think, the way that bathymetric data can be available for other non-traditional. When we say non-traditional, everything else but nautical charting. And for example, the DCDB, I think, is a great example of that. And you can download multi-beam, single beam, even some LiDAR data, marine LiDAR data from there to be used in any way you want. So that's, for me, the way to go and the most accessible tool to acquire bathymetric data. But sometimes some countries are kind of reluctant to provide detailed bathymetric data because they think it goes against their interests. And differently from US, here in the US, data collected by government is public because it has been paid by contributors through taxes. But in many other countries, unfortunately, they don't think that way, and they sell the data. And sometimes this data is quite expensive. Having said that, I see a trend to democratize, if you will, bathymetric data more and more. It's like 10, maybe 20 years ago, satellite imagery was very expensive and hard to find, and now it's very easy to access and cheap, and in many cases for free. I see a similar trend with bathymetric data, and I'm sure in the future it'll be more and more accessible.
Well, excellent. Thank you very much, Rob. I appreciate that. And I'm very excited about the Seabed 2030 effort. I mean, it's, fits right in with our, master mapping plan and our mapping network from the Alliance perspective. And I know several groups around the Gulf are working on collecting and compiling bathymetric data. So I'm going to keep an eye on that one for sure. So, all right. Anybody else have any other questions for our sponsor? Okay, so back on camera real quick. I think that's it. This is the end. We're going to close it out. We want to thank everybody for showing up today. Thank all of our presenters, not on just today's event, but all 7 previous events. I think we've had some stats on today, like 24 tools. We've had, Esri has been on there and sponsored all of them, so they've been able to provide, 8 very positive and informative presentations for this series. All of this information is going to be on our website. The recording is going to be there on the resources tab, all the way to the bottom, the tool time, the landing page there. At the very bottom is our resources links or resources document. So the videos will be there. All of the information that's been provided both here and previous webinars, ancillary-wise, is going to be available to you guys all. So I'm repeating myself. So at that point, and now that I'm repeating myself, it's time to sign off. Stay in touch. Keep your ears and eyes open, and we might be having more of these in the future. So with that, I don't know if you want to show the on location real quick, and then we'll give a big wave from everybody that's here in the room when they get back on. All right, so now everybody give a great big tool time wave, and we're out of here.
Thank you.
Thank you.
Thank you.